Okay, so now that we've talked about exponential functions and covered the theory behind exponential functions, now let's practice some of the things we saw there, particularly the exponential laws and properties with some problems from homework task 8. We're also going to be using at the same time some of the laws and properties of logarithms because these are closely related. So since you guys have to solve the even problems, I'm sorry, you have to solve the odd problems. Sorry about that. I'm going to work on the even problems here. Okay, and these are from sections 2 and 3 of homework task 8. So let's start off with problem 24. Okay, so I'm going to switch over here. And let's write down problem 24. So problem 24 says f of x equals minus 3 to the 2x plus 9. And it's asking us to, it is asking us to find the x and y intercepts of the graph. It's not asking us to do the graph, it's just asking us to find the x and y intercepts. Okay, so let's work on 24. So we've got f of x equals minus 3 elevated to the 2x plus 9. Okay, and just to be clear here, because we're talking about exponents, so 3, this is the base. In this case, the base is equal to 3. Okay, and so we're being asked about the intercepts. So let's try to find the x. Let's try to find the y-intercepts first. So the y-intercepts are going to happen. Let's remember what we've seen previously. The y-intercepts are going to happen when x equals 0. So we're looking for f of 0. Okay. So the y-intercepts are going to occur for this situation here. I'm going to draw this here on the bottom. So f of 0 is going to be equal to minus 3, and we've got 2x here, so it's going to be 2 multiplied by 0 plus 9. Now, 2 multiplied by 0 is going to be 0. So 2 multiplied by 0 is going to be 0. And so this is going to turn into f of 0 equals minus 3 elevated to the power of 0 plus 9. And so because of the laws of the exponents, I know that minus 3 or whatever number, in this case b, which is 3, elevated to the 0 is equal to 1. In this case, 3. 3 elevated to the 0 is equal to 1. And so, I don't like the way this 9 looks, so I'm going to erase it. And so if 3 to the 0 equals 1, then this is going to be the same as having f to the 0 equals minus 1 plus 9. And so the y-intercept, which is f to the 0, is going to be equal to 8. Now, I'm going to be anticipating a question that might come up here. Okay, wait a minute. You said that B, the base, had to be a number that's larger than 0. Okay, so why is there a -3 here? Well, actually, let's look at what's happening here. This element that I have here, this is actually -3 elevated to the 2 multiplied by x. So the minus is outside the base. Okay, so the base is 3. The base isn't -3. The base is 3. The minus is multiplying the result of the whole operation. Okay, that's why here it's actually, we have -3 elevated to the 0. And that's where we get this 1. Okay, so it's still congruent with what we were talking about. Okay, so now we found the y-intercept. Now let's find the x-intercept. And the x-intercept is going to occur for f of x equal to 0. And we need to find, remember that here we need to find the roots of the function, okay? Or the values that where it's going to be crossing an x. So now what we're going to have is that -3 to the 2x plus 9 is going to be equal to 0. And here is where we're going to be using some of the laws of the exponentials to manipulate this expression. Basically, we have to solve for x there. And so what are we going to do? I'm going to be playing around with the laws of the exponential. So first, I'm going to recognize that this minus is outside here. So we're going to say this. If I have a 3 elevated to the 2 to the x, this is exactly the same as, using the laws of the exponents, this is the same as having 3 elevated to the 2 elevated to the x. Okay. This is exactly the same thing, because remember, the laws of the exponents say that if I have a base elevated to the power elevated to a power, these two are going to multiply. And they're going to give me the 2x. So I'm just separating, okay? And I'm going to leave the plus 9 as it is. And this is equal to 0. Okay. Now, 3 elevated to the 2, I can calculate that. 3 elevated to the 2 is 9. So this is the same as having minus 9 elevated to the x plus, I'm going to remove the brackets because I don't think we need them. So 3 elevated to the 2 is 9. And it's elevated to the x. So this is the same as having 9 to the x plus 9. And this is equal to 0. Now I'm going to send this 9 to the x to the other side. And it's negative, so it's going to turn into positive. And this is going to turn into 9 equals 9 elevated to the x. Now here we're going to be doing some math magic. And what happens here? Notice one thing. Notice that we have the same base. In this case, the base is 9. Okay. The base is equal to 9. And so one thing that's interesting here, let's remember, now let's relate this to logarithms. So let's remember a property that says that the logarithm of a base b of b equals 1. So when I'm solving equations with exponentials or logarithms, the way I can eliminate a base or try to manipulate these is with the inverse function, which in this case is a logarithm for the exponential. And it's going to happen the same way when we're working with logarithms. We're going to be able to use the exponential as the inverse. So basically what I'm going to do here is say the following. I'm going to apply the same operation to both sides. So I'm going to say, I'm going to apply the log base 9, I'm going to use the same base of 9 equals the log base 9 of 9 to the x. Just to be clear here, I don't want this to be confused with the And so what's going to happen here? Well, first off, log b of b is equal to 1. So this term here automatically turns into a 1. And this term that we've got here is equivalent to having the x here, according to the laws of the exponents. The x can be brought over here, multiplied. So what we're going to have is this log 9 of 9 turns into 1. And this is going to be equal to having x logarithm base 9 also of 9. And so what happens here, the only thing I did is bring the x to this side because that's also another property of the logarithms. This is also going to turn into 1. And so what happens here, where is the x-intercept? The x-intercept is going to occur in x equals 1. Okay, so now we found the two, the x and the, y intercepts here for the exponential function. Okay, and it's not asking us to do the graph. Okay, it's not asking us to do the graph, but just as a reference, if we wanted to do the graph, this would just mean that the graph would cross for f of 0 or for x equals 0, then the graph would cross here in 8. And for y equals 0, the graph would cross here in 1. So without getting into much detail, the graph, at least we know that the graph would have to go something like this. It would have to cross, okay, and it would cross those 2 points. Okay. So now let's do another example. Okay, now let's do problem 26. And it's the same thing. They're asking for the x and y intercept. So let's look at problem 26. It's let's write it down over here. So we're going to have f of x equals x squared and that's multiplied by 2 to the x. And then we've got minus 2 to the x. And it's the same thing. We've got to find the x and the y intercept. So let's start off with, again, the y intercepts are going to occur for f of 0, or for x equals 0. So these are going to occur for f of 0. So let's see what happens there. F of 0, or if we substitute a 0 in the x, we're going to have x to the square, we're going to have 0 here, elevated to the power of 2, multiplied by 2 to the 0, minus 2 to the 0. And this is going to be quick because 2 to the 0 is equal to 1. 2 to the 0 is equal to 1. But 0 to the power of 2, this is going to be equal to 0. And so all of this is also going to be equal to 0. And so in the end, we're going to have f of 0 is going to be equal to 0 minus 1. And so this gives us that f of 0 equals minus 1. And that would be the y-intercept. That was relatively easy, right? It's going to be a bit more interesting with the x-intercept. So the x-intercept, or maybe it's not, we'll see. The x-intercept is going to occur when f of x equals 0. So we're basically finding the values that make the whole function 0 for the x-intercept. And so let's see what we can do there. Okay. So we're going to have x squared plus, multiplying 2 to the x minus 2 to the x equals 0. What could we do there? That's actually not that complicated. We've got the 2 to the x here. And if you notice, that's a common factor. So let's see what happens if we factor that. So let's bring out the 2 to the x. And so 2 to the x multiplied by x squared is going to be equal to x squared. Put that a little bit. So we're going to bring out the 2 to the x, factor that, and we're going to have 2 to the x multiplied by x squared. This is going to be x squared. 2 to the x, if we factor this, we're going to have a minus 1. Oh, guess what happens here? This is going to be equal to 0. And so this factor here We this is important for solving this equation. Well, first of all, remember that we're trying to find the values that make the function equal to 0. Well, there's two factors here. There's this factor, and then there's this factor here. Okay. And so for the first factor, for this one, we can actually eliminate it. And that actually looks like an apple. We can eliminate it. Why can we eliminate it? Because there aren't going to be any values that are going to make this 0. Remember, an exponential. So if I have a base elevated to a power, that is never going to be 0. Remember that we define the range for that. And also because we can send this to the other side multiplying, and it's going to be eliminated. So we're left with x squared minus 1 equal to 0. And what's going to happen here, this is the same as having x squared equals to 1. And if we apply the square root on each side, that means that x is going to be equal to plus minus 1, or x equals 1 and x equals minus 1. And also, I mean, just to practice our factoring, remember that this is also equal to x because it's the result of having a product of binomials. This is going to be the same as having x plus 1 multiplied by x minus 1, and this is where we get each of these factors. Okay, so from here we get x equals 1, and from here we get x equals minus 1. And so those are going to be the intercepts. Okay, and that means that for it's not asking us to graph, and I'm not going to graph the function. It's actually a more complicated function to graph. But what this means that for this function, f of 0 is equal to minus 1. So the function would cross here in minus 1, and then we've got 2 here. We've got the minus 1 here and the 1 here. So we actually don't know exactly where it's going to be. We don't know exactly how the function is going to look. The only thing we know is that it's going to be crossing in these 3 points. Okay, and so here we've applied some of the laws of the exponents. With these two examples, I think you should be able to do the other problems from, I'm sorry about that. With this example, you should be able to do the other problems of section 2. It's the same algebraic manipulations that we need to do, remembering the laws of the exponents.